Hello everyone, welcome or welcome back to my YouTube channel. So let's continue solving our coding challenge with this problem that asks us to create a JavaScript function that takes in an array of strings as input and returns a new array containing only strings that are palindromes. And I'm going to stop here because we solved a challenge on this channel where we checked if a word we were given a string, not an array of strings as input, and then we returned whether that string is a palindrome. So this question is like taking it up a notch where we don't just have a single string as input, but we have an array of strings and any of them could be palindromes. A palindrome is a word, as we all know, that reads the same forwards and backwards, and we want to return another array that contains the palindrome in a given problem. So we have this example input where we have level. Level is clearly a palindrome. We have hello, which is not a palindrome. We have race car. We have world. We have madam, and we have radar. So we can see from the output that level and race car, level, Risker, Madam, and Radar are palindromes. And we're also given a constraint that our input array may contain both uppercase and lowercase strings. This is important because if we are comparing and we have, let me write, we have Risker, these are capital uppercase R and lowercase r are not going to be the same thing. They have different there's this value, is it ASCII, that our code checks to determine if they are the same thing. So they have different values basically. Is it ASCII? I think it's probably not ASCII, but something relating the code. So I think R even has a higher value than capital R. And although they are the same word as we can see to the computer, they are not. So it's important to know that the array can contain both uppercase and lowercase strings, and it's important to also account for that while writing our code. Again, we've already solved a similar problem to this where we checked if a string is a palindrome. And that knowledge is important here because when we are dealing with arrays, we want to think granular, we want to think molecular. What do we want to do? We want to check if a single string is a palindrome, following off of that logic that we checked. Now, there are several ways that you might go about checking if a word is a palindrome, but in the last video, we used the two-pointer method, and so we will build off of that simply because we've used that before. So the two-pointer method basically initializes two different variables. So we have the first pointer on the first word in our string, the second pointer on the last word in our string, and then we want to do a comparison. If they are the same thing, we move our pointers forward to the next values. We move the last pointer forwards, we move the first pointer backwards. You get the point. And then we compare if they are the same thing. If they are, we move on and on. However, if we have a word such as, let's say, rat, if I have a word such as rat, and using our two-pointer method, we check if the first word and the last word are the same. If they are not, we exit out of our code immediately because it is definitely not a palindrome. So after we check that our words are a palindrome, we would then filter using the function that we've now created to check if a single word is a palindrome. We can now loop over our array and pass every string through our is a palindrome function, right? So we already have the function that checks if our word, if a string is a palindrome. Then what do we do with our array? We basically filter that array using the function we've already written, and then we save that to a new array and have basically our function that returns a new array. If that's, I hope that is clear. The point of, I want to say if that's not clear, let's jump at the code. But the truth is, if we do not understand it at a conceptual level, at least for me, if I don't understand at a conceptual level, it's very difficult to solve the code, to write the code, because the most important thing is understanding the problem. So just to go over, first, we are going to write a function that checks if a word is a palindrome. Again, if you need an in-depth explanation, you can refer to the previous code. It's going to be linked somewhere in the cards. We already went in depth using the two pointer method how to check if a single word is a palindrome. Now you already have that function that returns true or false if a word is a palindrome. Next, we are going to write another function still within the same block of function. We'll write another function that loops through every word of this array. Now, as it loops through every word of the array, we are checking with our first palindrome. If it is if it is a palindrome, if it returns true, we want to take that word that returns true and then save it to our output array. If it returns false, we're just going to skip it. If it returns true, we save it. If it returns false, we skip it and not return it in our new array. Basically, that is what our code is going to function like. About complexities, we are going to be using this code is basically going to be an O of n time and O of n space because our inputs can grow as our time rather can grow as large as the entirety of our input. We are going to check every word in our array. That's O of n as large as our input field is. That is how long our code is going to run for. And we are also using there's a possibility that our array the array that we return also contains all palindromes and so it grows as large as the input, in which case it's just a linear O of n complexity. Now let's jump right into the code. All right, so let's go ahead and define our first function, which is to check if the word is a palindrome. So we check is palindrome and our function takes in a string as input. And the first thing that I want to do here is to strip, and I should probably just use str, string. There's a possibility of it being a reserved word. Now, the first thing we want to do is to make string a lowercase because we have the constraint that it might come in lowercase or uppercase. After which we want to define our pointers. Start is the first word, the first word, and the end is basically last word in our the last letter in the word rather. So that's going to be the length of string minus one. Now we want to check that while our start is less than the end as it should be because start is the beginning, end is the last. While that condition is true, we want to check if string at the first index is not equal to the string at the last index because if they are not equal, then we just want to return false. If they were not equal, that means that it's not a palindrome. So there's no need to go over the entirety of that length. Okay, so let's just fix this. All right, cool. Now we will just want to return false and exit our code. Otherwise, we want to increment start and decrement false. What that basically means is this one is moving forward 0, 1, and this one is moving backwards, right? From -1 to -2 because there is no word after it, so it has to move forwards. I hope that makes sense. And if all of this condition passes, we never got to false and we've gotten to the end of this condition, then we want to return true. Afterwards, now we have the palindrome, isPalindrome that checks about what is a palindrome. Now we want to go ahead and define the function that returns if that word is a palindrome, and it takes in an array. And we just want to define, we're going to use the simple filter function. So filter is a method in JavaScript that returns an array if the conditions are true. So we want to check that the array we're getting in, if we filter that array, the filter is supposed to return a new array that we are saving into new array. Not very creative, I know. The filter loops over every word in our array, and for every word in our array we want to check if it passes this condition. So if it returns true, so we already defined is palindrome. Let me just give that space so it makes sense. So already defined is palindrome. Is palindrome returns true. So if any word returns true here, then we want to save it to our new array and return that new array. Now we can test that our code works. I've gone over and copied the actual test case from the code. We're given returns palindrome, pass in that palindrome, and then let's log it and see what we get. So we are getting an empty array, and that just means something is wrong basically. Let's look through our code. We are filtering. This should return true. Oh, I see what's wrong. String should not take zero. String should take start. Start should be dynamic, not zero. Let's run that again. And great, now we see that our code runs as it should. We have level, Riska, Madam, and Radar. If you checked out, if you watched the previous videos, or especially the last one, I like to test my code to be sure that they work as it should. So I'm going to go over and import assert, which is an inbuilt JavaScript function, and then copy over some test cases which I already have. So I've gone in and added the test cases. This code repo is on Replit and to be linked in the description so you can check it out if you desire. So we are checking for some cases that radar level and LO returns just radar and level. LO world level returns just level because LO and world is not a palindrome. We're also checking for when there is no palindrome at all, in which case we have an empty array because there is a possibility that there are no palindromes. In this code, I realize I'm not checking for if all of the words are palindrome. So let's go ahead and add that because that is a valid possibility that all of the words that we are giving is a palindrome. In fact, if we run this, we should have a case failure because, yeah, so basically we can see that it expects something different. It expects that all of these words should be returned in our array. It says the assertion is wrong. It expected all of these words, but this is what you actually got, just read scar. So we see that our test runs as it should. Let's copy that over and paste that here. So when we run this again, the assertion is that everything is fine. Let me delete the console, give ourselves more room, and we can see that all test cases passed successfully. I hope you learned something new and this was worth your time. Do check out other challenges on the channel and also try out different ways that you understand it best. Hello everyone, so editing Blossom here. I wanted to quickly clarify the space and time complexity that I caught wind of while editing. So the term complexity is actually not O of n, it's O of m times n. I'll put it somewhere on the screen. Simply because we are using filter to check the entire word. We're looping through the entire word of the array, which is O of n. But then for every word, we are also calling a palindrome, which loops through the letters of every word. So for every string, we are checking if that string is actually a palindrome. So we're checking the letter of all the letters of every word of the array. So the O of M here, we can represent the letters of the array is in the function is palindrome. So we are representing the length or the time complexity of each palindrome as O of m, since we are looping through the entirety of the length of the string, and then we're also looping through the entirety of the words of the array, so that's O of m plus n. Space complexity is still O of n because our array is definitely can possibly grow as large as the original array. And in is palindrome, we're not actually using an extra space. We're using variables to store specific values, but it's O of 1 because it doesn't change. So that has no impact, or O of n times times O of 1 is still O of n because O of n is basically larger. So I hope that clears that up a bit and is much more understandable. Thank you so much. See you in the next video.